Hey guys, how's it going? In this video, I'm going to go through this problem from Pramp, busiest time in the mall. So we are giving a data extracted from the door detectors, the mall stores detectors. So each data point is represented by a an integer array. It has a size of 3, looks like this, okay? And the value at the index 0, 1, 2, 3 are that. So the first spot is the timestamp over here, right? Second spot is the count of visitors, and then the last position indicates whether the visitor is entering or exiting from the mall. So 1 means that the visitor is coming into the mall, and 0 means they are going outside the mall, they're exiting. And yeah, so here this is example, and also we talked about the format of the timestamp. So given an array of data points, right? So we write a function find busiest period, and that returns the time at which the mall reaches the busiest moment last year. The return value is a time step over here. This is example. And if there is more than one period that with the same visitor peak, return the earliest timestamp. And also we know that the array is sorted by the timestamp. And we have to explain the time and space complexity as well. So let's look at an example like this. So I'm gonna bring you to Google Colab. I think it's easier to see. So this is exact same example that from Pramp right here. I'm just breaking up by different time step because for the first 3 data points, they are the exact same time step. So for example, for the first timestamp, there are 14 people going inside the mall, and also the same timestamp, there at the same time could be a different entrance in the mall. There are 4 people coming out from the mall. Also at the same time, there are another 2 people coming out from the mall as well. So in net, at this point in time, there are 14 going in and 6 coming out. So in net, there are 8 going into the mall, right? And as time progresses, in the next time step, there are 10 people going inside the mall. And then in here, 18 coming in and 18 coming out at the same time. So in net, there are nobody going in the mall. The next time step, 1 people coming out from the mall, and here 7 people going in the mall and 7 people coming out from the mall. So no gain or no loss of people. So we have to write a function to figure out the busiest timestamp. And for this particular example, it is this timestamp, which is this one. That's the busiest timestamp if we keep track of how many people in the mall. Okay. Yeah, I'm gonna go through my solution. So we can use a kind of like a brute force approach, which isn't too bad because it's just going through each of the timestamp and then figure out the net gain or net loss of people, a number of people at each timestamp, and then add it to the total, and then to see which timestamp has the highest total amount of people currently in the mall. And then we just recorded the busiest time, and that's it. Let's go through the function together. And first, we have the few variable that keep track of the status. So we have the previous timestamp, the busiest timestamp, which we will return at the end, right? And also we have the current number of people. I initialize it as 0. Also, we have a maximum number of people that in the mall. Also, I initialize it as the same as the current number of people, and current the net gain or loss of number of people. For example, for the first one, we have a net gain of 8 people. So I initialize it as 0, right? We'll go through this function a bit later. Let's go through this for loop first. So this is a array destruction, right? So for each of the data point in the data array, right? And each of the data point has 3 components: the timestamp, the number of people recorded at this record, right? So which is this position, right? And also whether it's entering or it's coming out from the mall, right? So I call it is enter, right? We will go through this one a little bit later. So if it is if is enter equals to 1, that means we are gaining people. So the current net number of people, we just add the number of people to it. So we have to so this current net number of people is to keep track of how many people we are gaining or losing in net for each point in time. So for example, we are gaining 8 people at this point in time because we gain 4 people and then lose 4 and then lose 2, right? So in net, we are gaining 8 people at this particular point in time. So if the people, not the visitor are coming in, so if is enter equal to 1, so we add to the net number of people. Otherwise, we just subtract from the net number of people, right? So this is keep track. This net number of people that's to be keep track of at each point in time. Okay, and if the current timestamp is not equal to the previous timestamp, that means that we are in a new timestamp. And when will this happen? It will happen when we enter to a new timestamp. So for example, when the for loop goes through here, so the current timestamp is not the same as the previous timestamp, which is the previous timestamp ends with 425, right? The current timestamp ends with 378. So the current timestamp is not the same as the previous timestamp. We can do the update, right? And how do we do the updates? We just call the update answer function, right? So we can add this net gain or loss of people to the current total number of people in the mall, right? So first, yeah, as I said, we add the net number of people to the current number of people in the mall, right? And then we put the net number of people back to 0 so that we can reuse this variable for the next timestamp. Okay, and if the current number of people in the mall is greater than the maximum people, and then we just update the busiest time because the current timestamp is the previous timestamp because we are already in this timestamp. So the previous one will be the busiest one. Okay, be careful, we don't use a greater than or equal to. We don't use the equal to because we need the earliest timestamp, right? So know if there is more than one period with the same visitor peak, return the earliest one. And that's why we don't use the equal to. We only use the strictly greater than, right? If the current number of people in the mall is strictly greater than the previous maximum number of people, we update the busiest time. Also, we update the maximum number of people in the mall previously. Okay. And after all that, we just return the updated variables back to the main function right here. And so we keep doing that until we finish the entire array in this for loop. And also, don't forget to update the previous timestamp. That will be when we move forward, the previous timestamp will equal to present timestamp, right? This is how we move forward. And that's the main part of this for loop. And for time complexity for this for loop is going to be big O N, because essentially we loop through each of the elements in this array. But don't forget, we have to update at the last time. Otherwise, it won't update the last time point. And why is that? Because as you can see that, so at this timestamp, which is exactly the same as this timestamp over here, right? And that means it won't, this update function will not be executed at the last loop of the for loop, right? It's the last call of the for loop, because the current timestamp is exactly the same as the previous one, as you can see in this case, unless they are different, right? In this case, they are the same, but we still do want to update the current number of people in the mall, right? So how do we do that? Well, we just call it one last time after we get out from this for loop, right? Just call it one more time. And yeah, at the end of the day, we just return the Busiest timestamp. So let's run that. Also run our mock data. And this is exactly the same as you can see from the question. Yeah, so this is my solution to this problem. I hope you find this helpful. Thank you so much for watching. See you next time.